Okay, so let's go look at the wave simulator and see. This was left from last time, but let's try to figure out how to make a wave for which the group velocity is zero. The group velocity is zero. So it's a question of how would we make that wave and what would that wave look like as time progresses, both at an instant in time and as time progresses. So group velocity zero, phase velocity non-zero, I should have said. So for a group velocity of zero, that means that since group velocity is delta omega over delta k, we want delta k to be non-zero, but delta omega to be zero. So I'm just going to take the wave I have right now and make delta omega to be zero. So omega 1 is 8, so I'm going to go over here to the second wave and make omega 2 equal to 8. So before I hit enter, imagine what that's going to look like. So now I've got omega 1 is 8, omega 2 is 8, so delta omega is 0. K1 is 8, K2 is 7, so delta K is 1. And the phase velocity, which is the average, the phase velocity is 8 plus 8 over 8 plus 7. So there is a phase velocity, right? The phase velocity is non-zero and exists. So what does that mean? Group velocity is 0, phase velocity is non-zero. This is the group, and this is the phase. So what should happen is that the group should stay still while the phase should move within it. Let's see. That is not the case. Sorry, I forgot to hit enter. When you change the numbers in these wave functions, you gotta hit enter. Okay, now let's go and see the difference. Oh, look at that. That is so cool. Look what's happening. The group stays still. The group doesn't go anywhere. But the phase, the oscillating term within it, is moving, right? The oscillating term is moving. So this is the phase velocity. I'm just following one of these peaks. That's the phase velocity. As opposed to the group velocity. Let me stay at the peak of a group. There you go. Group velocity is 0.